Hi everyone, myself Satvik, roll number 2095 at A05G4, branch Computer Science and Engineering, section B from 7th semester. The topic which I got for the Tech Talk is Big Data and Analytics. For the subject Big Data and Analytics is Communication Styles for Parallel Systems. In the world of big data and analytics, parallel systems have become increasingly important for processing vast amounts of information. However, communication can be a major challenge in these systems, as multiple processors and nodes must work together seamlessly to achieve optimal performance. Effective communication is critical in parallel systems for big data and analytics because it allows for efficient collaboration between different components and ensures that data is processed accurately and consistently. Without effective communication, parallel systems can become bogged down by delays, errors, and other issues that can compromise their effectiveness. Types of communication styles. In parallel systems for big data and analytics, communication can take on different styles depending on the needs of the system. Two common types of communication styles are synchronous and asynchronous communication. Synchronous communication involves direct interaction between components at the same time, while asynchronous communication allows for communication to occur at different times without waiting for a response. For example, in a distributed database system, synchronous communication may be used for transactions that require immediate consistency, while asynchronous communication may be used for batch processing of data. Another important aspect of communication in parallel system is whether it is centralized or decentralized. Centralized communication involves a single point of control, while decentralized communication allows more flexibility and autonomy among components. For instance, in a cluster computing system, centralized communication may be used for resource allocation and load balancing, while decentralized communication may be used for data sharing and collaboration among the nodes. Next, let's move to benefits of effective communication. Effective communication is crucial in parallel systems for big data and analysis. It can lead to increased efficiency, better collaboration, improved accuracy. When team members communicate effectively, they can quickly identify and resolve issues, leading to faster decision making and problem solving. In addition, effective communication can help prevent misunderstandings and errors that can arise from miscommunication. For example, if a team a member misinterprets a message or instruction, it can lead to incorrect results. By communicating clearly and effectively, team members can ensure that everyone is on the same page and working towards the same goals. Challenges in communication for parallel systems. One of the biggest challenges in communication for parallel systems in big data and analytics is ensuring data consistency. When multiple nodes when multiple nodes are processing data simultaneously, data it can be difficult to ensure that all the nodes have access to the same up-to-date information. This can lead to errors and inconsistency in the final results. Another challenge is scalability. As the size of the data being processed increases, so does the number of nodes required to process it in parallel. Coordinating communication between a large number of nodes can be complex and time consuming and can slow down the overall processing speed. Best practices for effective communication. Using standardized protocols is a key best practice for effective communication in parallel systems. For big data and analytics, this means that all communication between nodes should follow a consistent set of rules, such as using the same message format or encoding method. Standardized protocols help to ensure that messages are interpreted correctly and can be processed effectively. Minimizing data transfer is another important best practice. For effective communication in parallel systems, this involves reducing the amount of data that needs to be transmitted between the nodes, which can help to improve performance and reduce network congestion. One way to minimize data transfer is to use compression algorithms to compress data before it is sent over the network. Conclusion. In conclusion, effective communication is crucial for parallel systems in big data and analytics. By using the appropriate communication styles such as synchronous and decentralized communication, teams can improve efficiency, collaboration, and accuracy. However, challenges such as data consistency, scalability, and fault tolerance must be addressed to ensure effective communication. Best practices such as using standardized protocols, minimizing data transfer, and implementing fault tolerant mechanisms can help overcome these challenges. Again, uh, I would just like to say that effective communication is crucial for parallel systems. Uh, because as we all know that when multiple processes are running inside an OS or in a system, so parallel processing happens or parallel systems want to communicate with each other, like I have completed this work or I have completed this work, or they want to share a particular memory or share a resource, both if they want to access the resource at the same time, it may lead to deadlock kind of a thing. So to make this not happen, parallel system communication has to be effective. Like they can use some lock system, lock and key mechanism, or when one person is accessing, another person can't access that resource, they need to wait in the queue and stuff like that. With this, I have come to the end of the topic. I hope that you have gained some knowledge. Thank you.